Okay, I'm going to jump right into this. Here's your MaxJax. I want you to notice what happens when this is not bolted down. There's the weight forward. Just one of the arms, if you will. You see how it's leaning? Step back a bit for you. Well, that's the reaction. You see how it pivots from the front? And your raise position is here. Pivot from here. Well, that's the same thing with the stresses on the vehicle. When you put the vehicle out there, it's going to pivot. There's your plumb, and there's your rotation. So, this is the stone wall behind here. I'll drill into one of the stones, and I'll epoxy a rod into it. I'll actually drill, or use, if possible, use one of these holes. You know, if possible, meaning if I line up. If I don't line up, I could always drill another hole here, or just use a plate that would extend it out, a straight plate, if you will, out further, and I can anchor it in 2 points, 1 and 2, to distribute the load further apart, not in the same stone. That would give you, let's put that over there. That will give you more resistance to the rotation at the top. The bottom's holding it, otherwise it's all being held at the bottom, meaning I'm 100% dependent on the anchors at the floor. This now puts it up here and puts this in tension. These are in tension also in Pullout. After doing these holes, I inspected the holes, and these holes only go down. This one only goes down that much. I'm pretty much clear at that point. Now, let's try this one. Both of these holes suck. This one's significantly deeper. I don't want to put my middle finger in there, it might get stuck, but this one goes down further. It's not the 5 inches that they call for. All right, I don't have any cracks here. So what do? You take it all out, you put a footer in and everything else, like I did, like I'm doing out front here, right there, that one there. Or I'll show you that you can get a lot of value off this wall anchor and off the floor anchors. This is for your rebar pullout test I talk about with you guys, this is the tool used for testing rebar pullout. Anchor test, if you will. It's heavy as fuck. I will make another hole, not this one. This will not be my test hole yet. I'll make a sacrificial hole over here that I'll take to failure. I'll load it. I'll figure out what the reaction is with the vehicle loading and the distance. So the vehicle loading, the load out here, along with the distance, the bolt spacing and the rotation, and I'll determine roughly how much force is being really a force multiplier. Say it's a car loading is only 15, 17, 1800 pounds here. What does it really equal in the rotation down here? It's going to be force multiplied. It's going to be a lot more than you may imagine. It's not 1,500 pounds there. Out here, it's like a lever. This is a lever. It will be way significantly higher. I don't know, maybe 2,800 pounds. So I need a factor also. I have 3 bolts, 4. I like to have each bolt give me 2,800 pounds. These slide shield anchors, these wedge anchors, will not be what I'll use them sacrificially for with the video, but these will get epoxied in. Now there's a gap underneath the floor there, which there always is with these floors, a gap to develop over 50, 100-year floor, and so spray foam it. Just put foam down the bottom there to fill it up, so when you put your epoxy in, you're not just trying to fill up an empty hole. Do not use the screens. You can buy those screens for 15 bucks, drop it in there and fill it. I prefer you use the surface of the concrete as your anchor. The plastic screens can create a slip effect. I've not really used those screens under testing, so I'm stating that without actually ever testing one that I can recall the anchorage on that. Usually for low, not life safety stuff. But the crack foam, this is what you can do with that. I have a different foam gun that I use, not the cans, but I might use the can this time. So I'll foam the hole, and if foam comes up, don't worry about it. Just run your drill back down there, drill the foam out, vacuum it out, flood the walls, clean the walls real good, wire brush the walls. So you're going to wire brush those walls. You know, get them wire brushed real good. And then again, these I do not recommend. All right, I do not recommend them. These wedge anchors create a hell of a stress. It's a lot more. Epoxy is your better choice. Epoxy is. Now the advantage of this ball system is that these will stay flush. This anchor will stay flush once you unthread it. Yeah. Once you unthread it, you have a flush system to slide this over. Whereas the other one, other system I'm putting outside, the bolts will be poking into the air, if you will, galvanized, and it will be. I have to lift it up and set it over like that. Set it over the back too, and then this from the front's going to be a little more difficult. So we got to nail it. This is what they look like. This is smooth wall. Epoxy will anchor will do a lot of work at this bell. As this bell goes down the wall, it will want to push. All right, so it will want to clean the walls off, pushing the epoxy down and not really getting around the side walls here. Oh, okay, so I said I would use these anchors. Obviously, you now catch on the way I communicate. These anchors are useless to me. It will be a threaded rod that will go down there. So when you see the test done over here, it will be a hole, a threaded rod, epoxied. It will be set up, and then I'll put that threaded rod to failure in this system here. They just look like a clean hole through them. See them? And there's a gauge on the other side of hydraulics. You do the correlation between kilonewtons to ton force. And that's your answer. No more conversion needed. That's the ton force it takes to pull it out. So you figure out what you need based on your reaction, your loading, and there you have it. So these are expensive as hell. Probably, I don't know, $80 for the box of them. Useless to me, and that's why you saw me in the other video with the long threaded rod stuff, because that's the way to go. This wedge anchor thing, it sucks. And again, this will get tied into the wall. And as simple as drilling, making sure that you can epoxy it, lay the rods in. I've done this a lot in stone, and braced a roof even once with that I can recall with this system, with what I'm describing to you. So it's got some ballast to it. This stone is locked in. This stone, it's not what you think. Stone is not just can slide off like block. It's because if it's a regular shape, it locks in. It locks in. That's the header. It locks in, and you couldn't pull it out if you wanted to. You've got to destroy stone structures from the top down, unless you got a big enough machine to drive it all down. But you're not going to punch a hole in this and say, okay, I'm putting a window there. No. And it's so thick, the stone is. You're not saw cutting that either. So it works. This system that I'm describing to you works. Let's see if I can show you the stone. That's the stone that I'm going into. And so the load on it, 3,000 pounds, you're not pulling this wall through. You're not bulging it, buckling it, or anything. It's got the ballast. It's locked in. It is badass. It's a thick wall. All right, it is huge. I think it's 21 inches. All right, nevertheless, I'm going to distribute it. Like I said, I'll probably do or alluded to, I'll probably do 2 of them. And then angle iron, just an angle iron across the back, and then into the wall with both of them. Angle iron, it will tell me also signal. I shall have redundancy. That's got to fail on the wall, and it has to fail down there. So now out here, I don't have the luxury of pulling that over. All right, there's no luxury of pulling that over to the wall. There's a full garage in front of me. No luxury on the other side of there. So with this one, I have the luxury of doing that. So I'll take that. But more so, it's my pullout test. Once I do the pullout test here, I'll also do a pullout test over here at the same time. Then I'll do the values. But so this will be the most suspect one. And I could run a cable tensioning system where I just use an eye bar that can rotate, and I can tighten it with cables. Run it from the far wall. Let's see if anything's an image I want to protect. Yeah, I don't want anyone taking inventory. Not yet. A lot of stuff is I'm selling most of my stuff. I like restoring the older machines, the stuff from the 40s. So I restore these old machines. This is a 220 grinder. This thing's about $6,000 if you try to buy one, and then I just sell it to people for a nice price for them, just to, you know, be happy. I just like restoring them. This is the little one. This was also 220, which I have it now at 110. This one works. Always keep the sunglasses, safety glasses right on top of it. And I'm hiding behind the camera now, so just in case you try to throw something at me. And those little wires will blind you, obviously. Nobody uses these shields, so that's why the glasses. Alright, hopefully this gets you up to speed. And we'll continue there. Pull-out test. Here we go.